Welcome in to the Energy Tech Podcast presented by OpSite Energy. Today we are live from Tysons, Virginia at Inductive Automation's Data Center Discovery Day. Joining the show today, we have Arlen Nipper, President and Co-Founder at Cirrus Link. Guys, welcome to the show.
Hey, Jeff, it is good to be here at Data Center Discovery Day 2026 in Virginia, right here in Tysons, and along with a guest who we love having on the show, Mr. Arlen Nipper, the co-founder and president of Cirrus Link. Arlen, it's good to have you here at Data Center Discovery Day.
Hey, Mike, it's great. I love it.
Yeah.
This is awesome. Already, the first presentations were all about data organization, about, Ignition, MQTT, so we're already off to a really good start.
Yeah, Arlen, I was listening to that first kind of the opener there. And one of the things I wanted to ask you, because it's come up, I know you're going to wince a little bit on AI. It's something we're going to talk about because it's just a general part of the conversation. But before any of that, I want to ask you, in your mind right now, where does the unified namespace create kind of that most immediate value in the data center? Where do you see that going? Naturally, MQTT is a big part of that, but at the same time, in your mind, where do you see that adding value with the unified namespace?
Well, really, we have to realize that even with all, like the Prove It conference and with all the talk about MQTT, the UNS is not your MQTT server. The UNS is a platform like Ignition.
Yes.
So the thing about trying to use AI or trying to get that into, especially the complexity of where data centers are now, is that if I don't have a good UNS feeding contextual data in real time, then IA or artificial intelligence can't do anything with it. So if you don't get that operational layer done and done right, leveraging AI you can't even start taking a look at that. So the foundations of what Travis went through this morning, are crucial to getting that layer of operational data in.
Yeah, having said that, Arlen, so you talk about that foundation. So if someone does that, what do you think are some of the mistakes they're making early? And maybe the words mistake isn't the right word, but I think there's some things they make early. So I'll give you one example I know of, is people tend to think that the broker is the single source of truth, and that's not really what we mean, right?
No.
So I think that, in my mind, that's one of the early mistakes that people make, is that it's the broker. No, not necessarily. So I want to get your kind of take on that.
So my ultimate vision is that we have PLCs, we have sensors, we have like the water cooling.
Yes.
The
liquid cooling.
Liquid cooling
Absolutely.
they just talked about. Well, that's using Ignition Edge, so all of a sudden I can get a liquid cooling system that becomes my single source of truth.
Right.
So because those engineers, they built the liquid cooling system, they know what all of the process variables are, they know what the engineering units are. I don't have to poll that and then re-enter all of that data.
Right.
It's a single source of truth coming from my liquid cooling system.
Right.
So that is the ultimate of a single source of truth. But beyond that, I know that in the data center space, we've got a lot of BACnet, we've got a lot of Modbus TCP.
Right.
So that's really where you would leverage like Ignition Edge, but right out at the edge as far as possible. That way, when the engineers are configuring the BACnet IP or the Modbus TCP, they can give it the contextualization right there. I'm the engineer. I put in that 4 to 20 milliamp sensor.
Right.
That represents 0 to 200 degrees Fahrenheit. Now that becomes a single source of truth.
Right.
So now I can start deploying that Ignition Edge to provide that abstraction, if you will, from Modbus or BACnet IP. Because the problem is that if I bring Modbus up to the next layer, that means a human being has to edit it.
Right.
Give it engineering units, give it scale.
Yeah.
Or even worse, if I took it to a third level and had to edit it again, now if something changes in the field, if they go put a new 4 to 20 milliamp sensor in, and let's say now it's 0 to 250,
right,
they can change it at Ignition Edge, it republishes, and now all of my screens, everything are automatically updated.
Got it. And, Arlen, having said that, what I heard from you right now especially is that, I think I mentioned this to you before, I don't, maybe I haven't, but they use the euphemism of data engineers call it enriching data. That's an expensive way of saying, instead of getting that data right, like we're talking about, and creating that single source of truth, they tend to overdo that on the data side. And I think that's another common mistake that happens because maybe they're not doing that at the edge. And in your mind, because I've followed you, and in other industries specific to the data center, are you seeing where legacy protocols get in the way of creating that context, or not necessarily? There's ways now.
Well, there's still, you look at it today in Modbus in 2020. Modbus was invented in 1978.
Right.
And in 2026, the most used protocol globally is still Modbus.
Yes.
And I was reading an interesting article the other day that actually explained that, is that they said, look, we know we're going into an infrastructure that's going to be polling. We're cost constrained.
Right.
We can't put a 32-bit microprocessor on here to do OPCUA. We can put an 8-bit microprocessor with maybe, less than a meg of RAM.
Right.
We can do Modbus, and then our customers are going to poll us with something like Ignition Edge anyway.
Right.
So I think it's almost like the notion of edge compute has the sensor manufacturers going, well, we're not getting value for our product, so we're just going to still keep doing Modbus TCP.
Right.
But a flip side, again, the liquid cooling presentation that we just saw, perfect example of where I would like to see it go is now I plug in a new liquid cooling, boom, it comes into Ignition,
Right.
done.
Right, yeah, the same way you want to see any other edge node capability pop up when you're installing that, when
Exactly.
you see it, even if it is legacy in your mind, right, you can still see that. And so, Arlen, in the data center, if somebody's doing that, now let's say that they do bring that to the edge. We had a guest on just a little while ago that said, we're having to manage tons of edge nodes. We've got tons of edge nodes. The data center now wants to derive value from that. What do you think is one of the biggest challenges? I get it. MQTT is, let's say, 80% in terms of sizing when you talk about HTTP packets, right?
Right.
So we get that part. But that's an advantage. But what do you think are some of the, how do you address a challenge like that when you have multiple edge nodes regionally, maybe even globally? Where do you see a good fit? I think MQTT is still valid, but, in your mind, do you see that as a big challenge for using that at the edge and continuing with multiple edge gateways for Ignition?
Well, the demo that Travis did this morning,
Yes.
would show, right there shows you with proper tooling, managing 100, 200 edge nodes actually becomes a exercise in clicking a button and doing a deploy.
Yes.
Right? So we've gotten that, and then what we're seeing, again, like in the demo this morning, is typically we're seeing, edge nodes to gateways, then gateways to overall operation center gateways, or
Right.
remote operation centers, I should say.
Right.
So we're seeing that scale already, and with a little bit of kind of what's coming up.
Yeah.
You're going to see QTS this afternoon, and they're going to show a really good demo of that same technology.
I think you're right, and people label that typically like infrastructure as code. They've made it out simpler. They've been able to balance loads. So you went exactly what I expected to hear was you kind of see that and as the rise of infrastructure as code to make it simple.
Right.
And great. And I'm kind of moving along with this in my head here. We did talk about the edge. We talked about some of the legacy. So I want to address this because I know, having talked to you a few times now, at what point does AI actually become useful in operations if you've addressed the challenge, you've made use of your ability to move edge data? At what point do you believe AI actually becomes useful? And it could be data center, it could be anybody else.
Well, typically across the board, I mean, we know that every customer is looking at some form of leveraging AI, and I think that's perfectly viable. Now, I don't think we're ready to put it into the loop without the human there.
Sure.
But I think we're getting really good, and with the new module for ignition that lets you basically expose ignition internally to the tools that you want AI to look at. And then Chris Markstein showed a really cool demo in that instead of using MCP, he was able to export a file that ignition had captured directly to Gemini to do waveform analysis.
Yes.
So that was a 100% perfect example of leveraging AI right there at that point. And that demo, I mean, he should have pointed out more. That literally was taking a screenshot of a high-resolution waveform and sending it directly to Gemini and say, hey, tell me what's wrong with this power signal.
Right. Wow. So, Arlen, in your mind, having said that, when do you think it gets away from just being noise and starts becoming, hey, I don't think it's agentic, because I'm going to be careful not to use the word agentic.
No.
But in terms of this, there's human in the middle in your mind. When does Arlen Nipper feel that it's no longer noise?
Well, I think I have seen some examples of doing alarm analysis, and like right now, even at Cirrus Link, we use Claude to take a look at log files, coming from ignition. So for us, man, that is an order of magnitude better use of time, right?
Yes.
And so now I can start seeing as we move along, we can take alarm rationalization to that. And now, again, like in PID loop tuning, in watching thousands of analogs across time, a human being can't do that. Whereas AI could take time, then it wouldn't be a real-time SCADA system, but you could go back and say, hey, we need to tune this process, we need to tune that process.
Yes.
And get it ready for us to leverage the best of what we can do with AI today.
Right. And having said that, Arlen, when you come to events like Data Center Discovery Day, or you go to events, there's always a what I call a best foot forward, because you really want to have some possibility when you leave here, right?
Right.
Having said that, in your mind, if you've been in the industry a long time, so what do you think are some of the operational blind spots? If I'm in the data center world, what are some of the blind spots you need to look out for now? Like, if you said, hey, we want to try to address, legacy protocols. We want to optimize your data flow. We want you to consider that single source of truth as a strategy. All those things. In your mind right now, is there an operational maybe blind spot that they could be missing?
Yes and no. I think you've got, really the way I look at it, Mike, is you've got two generations of data center audience. You've got the ones that basically inherited the legacy way of doing data centers, but I think the next generation coming up are really looking at it, like Chris Markstein said, as an AI factory.
Yeah.
And as a factory, we know we have to get everything in there. But the interesting thing, listening to the history of data centers, is that 15 years ago, it was a real estate company with a big warehouse, and they go, gee, Mike, we can't rent out the warehouse, but let's put a bunch of computers in it. Oh, okay. And then after that, they said, we need to put in a bigger HVAC system. Yeah. Okay, we did that. Oh, well, now we need to put in a power management system. Okay, we did that. And so it literally came up in silo. But in today, like they were showing today, going from 100 kilowatts to 750 kilowatts in a rack in milliseconds, that's a real-time SCADA system.
Yeah, to ramp up, you mean, right?
Yes.
Yeah, so that's lots of possibility there, Arlen, and I think you know, for you, you mentioned that as a part of that. You know, that's a blind spot. It looks like that's what's happening. But let me ask it a different way. You know, what is the hardest integration challenge that you're seeing, right? Because everyone wants to remain hopeful for cooling, power infrastructure, you know, and compute workloads. But if they had to address one of those areas, what do you think that might be?
I think right now that it is the energy power monitoring. That still is, even today I've been talking to a bunch of folks, and it's still legacy Modbus. Here I'm the customer. I can't even get the right Modbus mapping from the equipment provider to poll with Modbus to be able to map it, to give it a single source of truth. So I think that's still, but then the newer part, like the racks that are self-cooling, the liquid cooling system we just saw, they're actually embracing it. So, you know, one of the reasons I'm here is that MQTT is really starting to dominate the entire data center automation market. So everybody I've talked to, they're using either, you know, generic MQTT, but there will be more presentations this afternoon on using MQTT and Sparkplug to really optimize how you're publishing your data in real time.
Yeah. So having said that, Arlen, I did want to ask you, I ran into you at the Intellect show, and, you know, you segued into this, which I think is great. A little update on Sparkplug and the foundation. You know, what's going on there?
Sure. So Wes Johnson and myself did a webinar about a month ago.
Okay.
And if people haven't seen it, they can go to Eclipse Sparkplug Working Group.
Okay.
And what we did was we reviewed the new version 4 Sparkplug changes that are going to be coming around. Now, I think the two top things that we've been asked for is that right now in Sparkplug, due to where we came from, you know, low bandwidth networks, we use Google Protobuf to really compress the amount of data that we're publishing.
Right.
But a lot of people have been wanting that in pure JSON, so that'll be available in Sparkplug v4. And the other thing that they're asking for is, again, we started by limiting the topic namespace, if you will, to 3 elements.
Right.
The group, device, and node.
Right.
But now we'll open that up and we'll let customers go as deep in the namespace as they want to go.
Right.
Now, that, you know, it's good news and it's bad news.
Yeah, what's the value in that, Arlen?
Well, I think there will be customers that'll go, oh, this is great. Let's turn on that topic expansion. Let's turn on the JSON, and they're going to deploy, and their network's going to go boom.
Yeah.
Because they're not going to realize how much that just increased their bandwidth. But a lot of customers do know what, you know, they know why they've asked for it. They want to be able to subscribe deeper down into the tag tree.
Yes.
And they want it to be parsable JSON because they've got the bandwidth.
Right.
So if they do that, and then there's probably a dozen or more cleanups. There's the issue with very, very large birth certificates on startup that we are addressing in the next version of Sparkplug as well.
Yeah, I think we ran into that as well. Talking about that payload size, right?
Yep.
Yeah, so I think that was something that even whether you're in data center, energy space.
Oh, it doesn't matter. It can be oil and gas, data, food and beverage, pharmaceutical.
Yes.
You still, because when we started, Mike, a big SCADA system, I mean, we've been doing this now for 11 years.
Right.
A big SCADA system maybe had 100,000 tags, or maybe 200.
Right.
Then it was like 1 million. Well, now we've got, you know, oil and gas, data center, manufacturing. We've got 10 million tags, 18 million tags. So we just had to refocus our attention because everything grew so fast and so exponentially.
Yeah, so almost, you know, a system that might pull in 1.1 million tags is I wouldn't say it's a drop in the bucket, but it's no longer the starting point anymore.
No, it's like
a small, you know, it's no longer the end result. It's the starting point.
A million tags now is probably now where we're starting.
Yeah, exactly.
Right.
So having said that, I know you're hopeful. You mentioned earlier that MQTT is. Do you see it becoming more prolific now in the data center, or has it always been? Because I do know some folks on site, they may favor things like Kafka things like that. But in your mind right now, are you seeing that being more prolific in the data center space?
Yeah, I mean, literally everybody I've talked to, and I talked to last night at the social event,
Yeah.
everybody's looking at MQTT and Sparkplug.
Yeah.
So I couldn't believe the number of people that tracked me down. They said, hey, this is great. Glad you did Sparkplug because we love it and we're using it.
Yeah. One last question, Arlen, because, man, we let you be here for a long time. We can't do it. So I do want to ask you, in your mind right now, if you had to dispense a piece of advice for modeling unified namespace, I know we talked about mistakes, but right now is a chance just for, here's my advice. If you're looking at this specific to data center, what are some of a few things that you might impart?
Well, again, just like when we invented MQTT, the funny thing, I look back in that, this whole notion of unified namespace, right?
Yeah.
Well, we were doing that in 1999 with Phillips 66 because if I remember and look back, we had Phillips 66, Pipeline 1, Booster Station 1, PLC 1, then we Pipeline 2, Booster Station 3. But the thing is that was a unified way of the data coming in.
Right.
And it's the same thing in data centers in that, hey, we know what a data center does. We know all of the real-time data.
Yeah.
If we can feed that into our Ignition UNS, right? Not the broker, but Ignition.
Right.
And then that goes up to a remote operations center, and we've used it. Now, there's an ISA thing on how people are organizing their UNS, enterprise site.
ISA 95 Part 2 for sure.
But maybe if that doesn't make sense for you, it's not an edict, right? It's
correct.
The unified namespace is look at doing it the way that you use data.
Yeah, you're right.
Right?
You're right. And ISA 95 Part 2 might do well if I'm in manufacturing, sometimes even in data center because they may not move.
Right.
But in energy, oil, and gas, guess what? That skid's going to move from location to location, right? So that's a difference.
That's
so
right.
That's some good advice there, Arlen. And with that, I cannot keep him, but I want to. But it's great to have him here in Tyson, right here in Tysons, Virginia at Data Center Discovery Day. Big thanks to Mr. Arlen Nipper. Great to have you on the show, Arlen.
Mike, always enjoy it anytime.
Yes, we love it. And thanks again. Don't forget to like and subscribe. Again, I'm Mike Flores, your co-host of the Energy Tech Podcast right here at Data Center Discovery Day 2026. Thank you, Arlen.
All right.
Thank you.
Good job.
Yes, thank you so much.